But before we get started, I want to say that we do appreciate the Cotton Commission, the Wheat and Feed Grains Commission, and the peanut checkoff dollars. So that your checkoff dollars is what's funding the research that we've been doing here. And we started that over and Brandon probably told you, in 1999 by the Cotton Commission funds. And so we've worked to continue to expand it into this demonstration site right here. And we've got a handout we will be giving to you after a little bit. But we've certainly learned a lot through drip irrigation, and even in the days when we first started putting in that subsurface drip irrigation was really kind of was kind of ahead of the curve in a sense, because not as many people had any RTK tractors, the precision guided sub-inch accuracy guided tractors to be able to install the tape and know where it's at and be able to work around it. And so we think that the components of bringing this system into focus are here now, and we're excited about it. We've seen a lot of good results, and some of the yields we were talking about while utilizing drip, have been extremely good. And and I'll say that the interest level is certainly going up, and part of our project is to just see how long that research like this is viable. How long is that tape going to last for us? And that's part of the research as well. And we're on the 13th crop over there, still making good yields, and so we're excited about it. We've had some school of hard knocks along the way as well. And with the first system we put in and the fittings we used, a little different than even what we recommend now. But the second system we put in here behind you right here, we had used the new and improved type fittings. Well, it crashed out on us because we was out there digging up fittings all the time, all over the field, to the point we said, well, that's just not going to work. So the point being made is it's our job as the experiment station to try to work to find the issues, the problems, the concerns, the disasters, etc., before it makes it to your farm, so that we be able to better advise you. And so we think that we have found the type fittings that you would need to successfully install your drip tape and to be able to work and manage it. And I'll say, it's certainly can make a good farmer a better farmer. It's not going to make somebody that doesn't manage their crops be able to manage the drip system effectively. So, Chris Balcom, the peanut agronomist here, we work closely together along with Brandon Dillard, our regional agronomist, and we think we've got some good suggestion on drip fittings. And somebody tries to sell you something that's new and improved, please give us a call first, and so we better advise you. And so we're kind of impromptu, and if you got any questions, you can certainly ask it. But I'd like for Chris to go ahead and go over some of the fittings and the hookups, because that has been the real trick, in my opinion, on making a system like this work.
Thank you, Will. Like Will said, there's not a lot of people that install this. There's not any one particular company that just go in and just does installation for subsurface drip. So we thought that it would be a good opportunity right here to take some time, because it's early enough in the year. A lot of people are interested. You look at some of these commodity prices, and since you're thinking about subsurface drip maybe for next year or in the future, maybe give you an idea of what it takes to install some drip, to let you know, hey, it's something that that is achievable. You can get it done right there on the farm, and it's not that big a deal. And we want to show you through some of the experience that we've had and some of the fittings there that we use, and just kind of give you a basic rundown on what to do as you prepare and get ready to do some installing. Number one, the first thing you're going to need to do is you need to know what kind of water source you're going to have, whether it be surface water or well water, and how much water you have available right there that you can pump, so that the system can be designed to fit those specifications. Now, a good general rule of thumb is you need probably around 15 gallons per minute per acre. So just for easy figuring, if you've got a small 10-acre field off to the side, you're talking about 150 gallons a minute to water that 10-acre field. Now, you don't necessarily have to have that much at one time. You can split that 10-acre field into 3 zones, and then you wouldn't need but 50 gallons per acre per minute. So if you had a lot of 4-inch wells, can pump 50 gallons a minute. So that's very achievable, and we have a lot of 10-acre fields scattered around the area. And that's what makes drip irrigation a huge benefit. Doesn't take near as much water. You got small irregular shaped fields, so it's a good fit for this area, and having that GPS technology to keep up with it, that was one thing that was holding us back. So once we determine that and decide where we want to put it, we want to look at, first thing is doing is plowing in the drip tape. This is one of the plows that we use to plow in the drip tape with. You can see we had 3 shanks. We plow in 3 rows at a time. The tape's 6 foot apart. To begin with, we've done a lot of research with 3-foot tape and 6-foot and compared them. The 3-foot spacing was no different from the 6-foot. You had half the amount of tape cost in a 6-foot. The 3-foot cost you more horsepower, but you could water the ground quicker. Me and William went to Texas back in '04 and was able to look at some of their research there. They were testing a lot of the same things we were, and they were seeing a lot of the same results. So we feel pretty confident that the 6-foot spacing of the tape is adequate. Less horsepower, just takes a little more time to get the crop watered. However, you're watering every day with subsurface drip anyway, because you're putting out small amounts of water. Now with the plow, one thing that we did is we run a strip till plow just ahead of this plowing in the tape, so we can eliminate any of those hard pans, hard spots in the field, or maybe roots or rocks or anything like that. We're kind of clearing the path to plow in that drip tape right there, so we don't do any damage to our tape, because that's one of the things. You may have a few nicks or something when you plow it in, and the depth we're looking to plow in depends on the soil type. If you like here, we have a good Dothan soil. The clay's about 15-16 inches deep, so we laid that drip tape right above that clay, and so it's about 14-15 inches deep right here in Headland. Now if you don't have any clay down there, what you want to do is just put that tape, move up shallower, and we recommend putting it about 10 to 12 inches in that sandier type dirt. Now you may hear a lot of talk about this shallow drip tape, which is the tape that's about 3 to 4 inches deep. We've done a lot of work with Dr. Ron Sorensen over from the Peanut Lab in Dawson, and that's a little bit different type system. That real shallow tape like that is a little cheaper tape, and it's short-term use. It looks to be there about 3 to 4 years. It's a thinner tape. It's an 8 tape. This is about 13 to 15 tape. So you got 2 different type systems right there. However, it's about a third of the cost compared to this other type system. But it's going to last a lot longer and give you a better return on your money. So once we go in and pre-subsoil that, plow in our tape, we're ready then to get to a little bit more of the heavier work that comes with it. We'll go along the edges of the field, wherever you want to stop that water at, and trench across there and cut that tape. That trencher is best to take just one of the riding trenchers, cut immediately across the tapes, and that trencher won't pull or move that tape or stretch it. It'll just cut it right into as it's laying, so it won't do any damage to it as the trencher goes across. You want to just run that all the way around the field on each end of the field, because you're going to have to bury the pipe for this type tape on each end of the field, because you want to pressurize this tape. That shallower tape is not like that. You just have a header pipe on that, where here you've got a header pipe serving it. It's connected on the other end of the field just as it is here, but that's the flush end. That's your footer pipe on that end. After we make that trencher across there, we found there over time it was better just to use that size trencher, what you needed for the size pipe. Here for instance, we've got a 3-inch size pipe, and you got a trencher there that's cutting about 4 inches wide across there. Therefore, you don't have to do near as much shovel work out there, because when you go to putting this in field size, that shovel gets old in a hurry. So what you want to do is just glue your pipe together across and have it suspended right above that ditch, so you can look in there and see where your drip tape lines are. And then you will come in there and get it all glued together. As you come back, you'll take some of these stage bits and drill your holes in your pipe for these saddles or for these other type hookups, depending on the size pipe you got. And what we found was that these stage bits work way better than just a regular drill bit drilling into this pipe. Very hard to drill with those regular bits, and once you go through, most times you'll go all the way through the bottom too. You'll hit it and damage it enough, and then you've got a problem. So we found these stage bits. They'll go real fast, real short, and then they'll never go through the pipe all the way to the bottom, even in the 2-inch stuff. So that makes it a lot simpler, a lot faster installation. And once you've drilled those holes where the tape is, you'll come in there and on this, whether it be 6-inch, 4-inch, or 3-inch pipe, we like to use the saddles because these saddles just simply glue right over that hole. And one thing that we found was with this 2-inch pipe, they made some 2-inch saddles. Now with the 6, 4, and 3, those saddles, like you see here in my hand, it's a lot flatter compared to that 2-inch. A lot more surface area right there. You can just press it down and hold it right on that pipe and it'll glue and stay there. On that 2-inch, it didn't matter how much glue you used or how hard or how long you held it down there, it'd still rise up in places, create a leak. And that was a huge problem that we had. So we went to a little different system with them, and we used a 5/8 hole with a little rubber grommet, and then this hose barb stuck in there, and then you tighten down that plastic nut and it won't move. Now I don't know how long that rubber grommet will last, so we just use that on the 2-inch pipe. All our other, we still use the saddles because they hold, and there's nothing but glue in that plastic, and I think it'll be there as long as we want to be irrigating, I believe. So once we get that set up and we glue on our saddles and we put this flex compression hose on there, then we'll just drop it right down into that ditch. So there we only have that narrow 4-inch ditch at the end of the field. Very easy for the tractor, like over time before you don't have a lot of dirt there that's going to settle and want to create a place to crimp this hose. So once you drop that compression hose in there, you can drop it down into the ditch, and then you've got it sitting down in your ditch like this. Then you can take your then your drip tape will be coming out of the field, and then you'll just simply dig down where your dripper line is, get it down to the depth. You want your pipe on these your header and footer pipes to be, say if you're at a foot depth with your drip tape, you want to be about 2 foot deep with your pipe. That way you're coming up about a foot higher and just bending it over gradually, so you got a nice smooth bend and you're not crimping the hose, restricting the water flow. You just dig down to your tape. Then we're using this hose barb that sticks in the compression hose, and then we've got this nut that just slips right up on the tape. It'll hold like you can't pull it off, and it's still up tight. It's a very good system. We haven't had any problem with this, with them lasting. We had some others we had mentioned earlier. Every time the tractor left the field, we was back out there trying to dig and tighten and tweak with them. That just wouldn't work. So now, once you dig down and connect it to that tape, it's laying down there a foot to 15 inches, however deep your depth is. But that's firm soil all the way underneath this hose, so you don't have to go back and do any hand work. You can take your box blade and just straddle that ditch and smooth dirt over it. And you've eliminated a lot of back-breaking work right there compared to if you'd used a backhoe. So then you got it hooked up. One of the key things is you know, you're gonna have whoever you want to buy your supplies from, shall I say, they'll have your engineers there to draw out the system for you, even though you're going to install it yourself, and they can tell you on the scale what size pipe you want to serve it with, whether it be a 6-inch, 4-inch, 3-inch, or however you need to stage it down, and it'll be a scale on that piece of paper for you to draw and follow, to where you can set that to it. That way everything will work accordingly. Having the air relief valves in there, they'll show you where to put those at, you know, at your high points of elevation, and let that air out, because that's going to be the life of your tape. You don't want to have too much pressure there or trap of air somewhere in there and expand that tape more than what it can stand pressure wise, blowing up, and then it's going to fatigue that tape and wear through. You know, that's going to hurt us over time. So with that being said, I'll turn it back to William, or we'll take some questions, something that might be on y'all's mind right now about installation.
I don't know if we said it or not, but we're installing this tape as 6 feet apart, so one tape is going to service 2 rows. And Chris and I, as he said, we went to Texas back in 2004, and some of their research was showing that one tape for every 6 feet apart, as opposed to one tape every 3 feet, was the same equivalent yields. And that's one thing that we set up this project right here that we eventually abandoned, is we did have a comparison between the 3-foot tape and the 6-foot tape, and we saw the same thing in Alabama as what they did in Texas, and so that made us feel good about our research data, that we were actually able to, that's going to cut down the amount of tape you're going to use, and going to cut down the number of fittings, and going to cut down the number of opportunities for any leaks, for any issues there. And and so, but we're going to apply that tape in at about a 10 to 14 inch depth, and and as far as water to service this field, as opposed to something like a pivot, we can zone this water out. So if you had like a 250 gallon a minute well, they could probably water 33 acres of land, as opposed to if you had 33 acres you need to put a pivot on, you probably still need 500 gallons a minute. So the cost of water development here with our aquifer like it is a concern. The first system over there, we are coming out of a well. This system right here, this is the demonstration. And I don't know if any of you have been by here a few weeks ago, and you could see where some of the crops were shorter and some were taller, and maybe the peanuts was narrower and more wilted, and some was wider and growing well. We got 1 acre block of dry land versus 1 acre block of the irrigated, and we do it for all 3 crops. And this system right here, we're actually pulling out of the ponds that we have over this way, and so we wanted to do it both ways. And of course, filtration is very important, and the disc filter here is, it'll clean itself ever so often, or if there's a pressure differential there, then it's going to kick and clean those disc filters. And so you certainly want to be automated. I think that's one of the beauties of this system, is we're looking at putting out 3/10 of an inch a day at peak water demand, and it can be designed as such. And as Chris said, this is the plow that we use to plow in the tape. And then of course when when we run out of one roll and we're going to put on another roll, then we want the emitter, as you might be able to see in the tape, and we got it at 2 feet spacings. And of course you can get different spacings on that emitter, but this is the emitter spacing that we've done here on the research station with 2 feet emitter spacing. We think that'd be the emitter that would be desirable for you, and one reason is because we want that water to wet on out as far as it can before it meets the water coming from the other emitter, because once it does, it's going to turn and start going down. And so when we put a roll of tape on there, and when we finish out that roll, then we're just going to grab it, we're going to flip it around and tie it together. Just a little quick, easy tie there, so that whenever that'll allow it to stay in line one another, where the emitters will still be on top. It's not twisted or anything, and it rolls right on in. When it comes out in the ground, then you're going to fall in there and you're going to take your scissors. You'll need to use scissors because you can get a good clean cut, and you just cut this knot out, and then you're going to put one of the connectors in there, and you'll just slip it on, and then you'll take that nut to tighten it down. And once you've tightened it down good and tight, as Chris said, it's not going anywhere. And
as he mentioned about the different tapes and the type of terrain that you may be on, not all the land is flat, and you can certainly put it on the rolling terrain as well. Some of those pieces of tape that y'all have out there, I think all have the typhoon type tape. They all have long emitters on them. Here is some of the PC tape, which is pressure compensating tape. It has a round emitter on it. You can see with a little flap on it. That's so that no matter if it's at the bottom of the hill or at the top, as it's pressurized, it's going to put out the same amount of water right there, regardless of where it is, its location in the field and elevation, due to its pressurized.
The first 7,000 pounds to the acre peanuts we ever made came off of that site right over there. Of course, good rotation is part of it, but drip irrigation, I think, is the next part of that equation too. We've hit it a couple different times, and we've made very good yields, and you'll see that in some of this handout here. And we've seen, you can see some of the research from a long term as far as when we was originally putting that in cotton there. And the yields might not have been quite as great over time as what I think we can see now. I think the genetics of some of these cotton varieties are much improved as opposed to what the genetics we had 10 plus years ago. So we're very encouraged. We think all the components to the puzzle are coming together. That being conservation tillage with cover crops. We want to make sure we keep something growing on this soil so it doesn't wash away. The RTK tractors, so we can fly in the tape, know where it's at, work around it. If you're sub-inch and if you're in between 2 rows, you're 18 inches over if you're on 36. you know, even if you got some implement drift and you're in a few inches back and forth either way, we're still well away from where that tape is at. So I don't know how much time we've got, but I was wanting Josh Brown to say something about if in this handout. I guess I'll go ahead and see about giving this handout. Working with his Pure Sense irrigation sensors, then one interesting fact here is, Brian, how much water we've had here, right here in Headland, since we started raining just after the 1st of August there?
Here we've had close to 7 inches, 6,
Okay.
8 or something like that.
6, 8 inches or so, okay.
But that was in 21 days, that was 50% of the time we got a rain. And so there were a lot of small rain events.
Right, okay. All right, you would think with 8 inches of rain, and that's one thing I was wanting Josh to kind of mention, and he can show. You would think with 8 inches of water, and of course now when we started raining, we shut the water off on this subsurface drift because the water that was available to the plants. But you'd think with 8 inches of rain that once it started drying back down, that your non-irrigated and your irrigated would really be moisture level in the soil would be essentially the same. And that's one interesting fact that I had noticed. And of course, this is my first year working with this technology. Josh has worked with it a lot. Now, he's in the business of doing it. And I'm gonna learn more through time. And that's the reason I wanted to know. I asked Josh if he would mention something about that.
Yeah. One thing I've noticed, we do a lot of work with soil moisture monitoring down. We've got sites in Mexico, to Tampa, Florida, over in Georgia in Peaches. So we've got it spread out up in Missouri. So we've got a lot of different soil types and a lot of different crops on that. But the one thing I've noticed, and it's the same thing, we've always assumed that when it rains or when you get an X amount of water, that the water bank in the soil is going to fill up at the same rate. And one thing we've noticed with irrigations is that sometimes it takes multiple rains to really fill that bank up. And part of the reason is that the soil below, when it's drier, it's going to pull more of that moisture down. It's going to naturally move down. So sometimes it takes a lot more water, for instance on drier land, to really hold and to really fill up. And in the top sections, it's going to hold generally more water than you anticipate. We've got test plots here. We've also got in Clayton, in center pivot, and generally they were putting on about 1/2 inch to 3/4 of an inch at a time, and we always thought, well, that's adequate water. What we were finding is the only amount we were reaching was like maybe 6 inches. But when you look down to 12 inches, it was drying out. It wasn't even spiking. And so what we ended up doing there was bumping it up to 3 1/2 inch applications. And so then we found with that we were getting the adequate moisture to move down. And in this situation, subsurface drips, it's different. You know, we've got it was 12, 15 inches deep depending on the plots, and so the moisture is already at that zone, so what you're actually getting there is moving up and down. But with the moisture trends, what we're able to do is actually keep the soil at the optimum level, not too wet and not too dry, but try to keep it at optimum level, and drips, the key to that is to keep it at optimal level for the plant growth. But you can look at these like on the 12-inch sensors, if you'll notice on the top of your page there on node 1 cotton, you can see if that large rain, that big spike, once it's spiked up and leveled back off. But you can look, that's generally typical. Once you get that heavy spike and it flattens out, that's typical drainage. And a lot of that may be because the soil is at fill capacity, and some of that also may be because you're having more of a movement downward because of the attraction is stronger. But you can notice on the dry land that it did not peak as high on it, but it also dropped at much faster of a rate, did not last as long. And that's part of the research and stuff that we're wanting them to do, is try to find out what the optimum levels and how to target those irrigations to really meet the needs of the crop.
Okay. Got any questions?
You have flow meters on there, and that way you can monitor that flow meter from the start for running a certain length of time, whether you're at, say, 12 hours, and just measure that amount of flow that you use there for that known amount of drip tape out there. Continue to look at that and monitor it. If you've got a leak out there, you're going to see that flow rate change. If you see the emitter stopping up, you're going to see that flow rate change. You know, it's going to change it. So, you know, you can't, that's one of the flaws to the subsurface drill and people are worried about. You can't visually see that tape running like you can look across there and see that irrigation pivot running and see those sprinklers. But through that flow meter, you can monitor it and know that it's putting out the adequate amount of water by watching it and its consistency with that flow meter over the time.
And if it does come a leak, it's gonna come boiling up to the top. And we just have to take a good shovel and dig down to it, take our scissors, clip it out, put our splice in it, tighten it down, and cover it back up, and keep on going.
I can tell you, after working with both pivots and drip, hard hoses and everything else, that you would think that, well, that drip, I don't know, it's just, I can't see it and I can't water the crop up with it. I just don't think it's worth it. But I tell you what, you're gonna save 20% of water with the subsurface drip. You won't have any flat tires with the drip. The tornado's not gonna tear it down and tear it up. The people are not gonna steal the copper off of it. And you're not gonna have all the seals to leak on it, like with the pivot to change out, and you're not going to have all those micro switches to get out here and figure out which motor's going out on the tower to make it run right. There's a lot of problems with the pivot that people don't realize. And there's nothing worse than having a flat tire in the middle of the cornfield, I can tell you. Because you're going to take out a lot of corn getting there and you're going to have a lot of sweat there, dude. So the drip is another good source, and now that we have that technology with RTK, it's certainly a viable option here for this area.
How often do they stop up the sand?
With the filter system, you're not really going to stop them up. The filter is going to trigger by pressure. Either you have it on a 5-pound or 10-pound differential. So whenever it hits that pressure difference of that much, it'll automatically trigger that filter to flush out. And so that way it keeps it clean going to it. Now if it sits there and continues to flush and not allows it to run, that tells you that your water, if you're, say, coming from a surface water source, that water is too dirty. Say it's a river and it's stirred up from a rain, and so it's got a lot of grit in it, sand in it. That could happen. It could sit there and continue to flush, so you just say, well, we're going to have to shut down until that water clears up. Coming from the well, you're not really going to have that kind of problem. You're still going to have to filter that well water, but that's the way to look at it. We haven't had any stopping up problems here, and I tell you what we do. We have these flushes on at every zone, or if the whole field is irrigated and all in one zone, you're going to have a flush at every corner, every end of that pipe. And weekly, as you're watering that field, you're going to open those flushes once a week and let it clean out. You can visually look at that water and watch it clean out.
But one of the things that I like so much about it, we have such small, irregular fields here in Alabama that doesn't lend itself to being financially feasible for a pivot system. And I don't know that he wants me to put him on the spot or not, but I know even Kyle Hovey here has been looking at putting in a pivot. And I know gaining some information from Brandon Dillard, you know, by the time you look, you know, it's half circle, and by the time you look at your water development and the pivot, you may be at around the $4,000 an acre range or so. Whereas, you know, if we can put this system in, then, you know, we may be looking more in the $1,100 to $1,500, $1,700 an acre range. I know it's kind of getting on the high side, but you know, it depends on what kind of lengths you have as far as tape, because you're still going to have the same amount of fittings on each end, whether it's shorter or if it's longer. And so that's the reason the variance in the cost per acre. But you know, it can bring feasibility into being able to irrigate smaller fields, as opposed to somebody really have to kind of say, well, how bad do I want to water at $4,000 an acre? You know, but if you look at that handout and you're seeing a doubling of yields and so forth, you know, with that, then all of a sudden payback can be pretty quick.
Do y'all think it's smart to just go ahead and figure in, if you don't have a GPS capable tractor, to figure that in as a cost with this system? Or
it's going to be a necessity.
Okay.
You're going to have that there. The only other way around that is somebody that installed it for you, plowed that in, and then they planted that first time for you, something like cotton or corn, where you left those stalks there, so you would have something to go by for a few years if you did not, and then you could maybe after 2-3 years you could then, you know, add that tractor later. But you're going to need something there, guidance, to be able to keep up with that tape where it is.
Any other questions?
What about with the water underneath?
You know, we haven't went to no-till yet. Now that we've had some set up for a number of years, we want to start looking at the no-till compared to strip-till and see if we can see a difference there. I think there would be a plus there, but these coastal plain soils that we have in this area, they are known for compaction. And I think we would still have a benefit and a little higher yield if we did do some minimum tillage such as the strip-till there in the place of it.
What about the difference in the length of the rows? Say you had a field, you was gonna put the drip on it at rows 5,000 feet long, and you come down to rows 100 feet long. You use the same size tape?
You got different size tapes. This right here is a .875. This will handle the longest run that you can do, which is 1,250 foot. So if you've got half a mile rows, 2,500, you're just gonna simply cut across the middle of the field, have your header pipe right there, and you're gonna feed out drip tape each way. So you go 1,250 this way and 1,250 the other way.
But you don't have your flush valves on the outside of the field. You wouldn't have those flush valves, anything in the center.